Hello there, this is Venkat Subramaniam. Welcome to the talk on a few new cool features in modern Java. I'm excited about where Java is heading in recent times. Java is focusing on bringing some amazing functionalities to programmers around the world, but part of that is reducing the ceremony so we can focus on getting our work done rather than fighting the language and the details we have to deal with. Well, obviously, if we can spend more time writing code, that leads to more productivity, and we can also get our work done with providing value to the customers. Well, that's what I want to focus on, some features in recent times that can help us quite a bit to get our work done. Let's start with one thing we have seen quite a bit, but which can be really leading to bloated code oftentimes. Well, that is about casting. Who really likes casting? You know what you want, the compiler knows what you want. Why waste the time in ceremony? Well, that's exactly what we did in the past Java. Let's take a look. For example, let's say we have a function which is going to receive and process some kind of messages. So we'll call it as process. It takes an object, could be any number of types of messages, hypothetically speaking, and we'll call this as input. So you've taken the pain to ask the question, if the given object is an instance of, let's say, string, and if it is, you want to do some work, and you could probably say, got a string, for example. Well, what do you do otherwise? We could simply say, got something else. Well, that's all makes really good sense so far. Let's go ahead and call this. We call process with a 1, and maybe we'll call process with a hello to just try this out and see what it wants to display. Well, it says got something else when we passed a 1, but of course when we passed in hello, it said got a string. But I want to examine the string just a little bit more. So what am I going to do? I'm going to maybe print out the length of the string. So we could say got a string of length and display the length. But how do we get the length after all? Well, we could say length is equal to, and then input.length is pretty logical, isn't it? But when you try that, you get an error. It says method length is not available on the input. But wait a minute, I just checked to see if it's actually a string, and why can't I get the length of the string? Well, unfortunately, in this case, what we have to do is convert this to a string or cast it to a string and put more bandages around it and then ask for the length. And it says a length of 5, as you can see. But that is a lot of ceremony, isn't it? How does this feel like when you write code like this? This is like talking to somebody to whom you say, hey, did you go to the movie yesterday? And they say, yes, I did. And you ask, how was it? And they say, how was what? You're not going to have a conversation with them after that, isn't it? Well, that's the whole point, is Java seems to have a very short-term memory that you asked it if it's a string, but you have to remind it again to cast it to a string. Why bother? Well, that's a lot of ceremony. I often ask the question, do you work for the compiler or does the compiler work for you? Well, right there, we were working for the compiler. The compiler comes around and looks at it and says, how's it going? And you're like, I'm working. And the compiler says, yeah, keep going. I'll be right back after lunch and check on you, and walks away. Well, that's not a good way of programming. Well, this is where the smart instance of, as I'd like to call it, or the pattern matching for instance of comes in. So what can we do with this? Well, we can pretty much do the casting in one shot. So for example, we can do a stir over here, and instead of that ceremony of casting, we can simply say length is equal to and use the new variable we introduced, which is str, and ask the question. So right there, we told Java that when you perform the instance of check, if it is truthful, then of course give me a variable which is of type pointing to the same instance, referring to the same instance as the other one, but of type, the desired type that you casted it to or checked for. So that's basically what we did here with the using the if statement. But you can also use this in a multiple ways as well. For example, suppose you wanted to check if it is of string, and you also want to know if it's of a certain length before you actually worked on it. So you could pretty much put a little and over there and say stir.length, for example, is greater than, let's say 4, only then do you want to process it, not otherwise. And of course, if I said 14, you can see it says got something else. So you can do this concatenation or short circuiting and more complex expressions where you can evaluate and carry over that variable as well. Now, clearly, because of short-circuiting, if the variable was not a type string, it is not going to come into this area, so that's pretty darn safe. Well, that's one of the things you can do, first of all, is this beautiful smart casting or really pattern matching with instanceof you can use very nicely. Well, that takes us to the next feature I'm really thrilled about, a switch being an expression. Well, it turns out that statements are somewhat evil, nefarious. Why? Because statements perform action but don't return anything. So by their nature, statements force us to have side effects. Well, in true functional programming languages, we only have expressions and not statements, or at least not that many. And the reason is because they want to promote immutability and lack of side effect. Well, in the case of Java, we've had statements and expressions all over. But switches now are not only statements, but they're also expressions as well. And that's lovely. Let's take a look at an example of what that means. Let's call again a function called process. But to this function, let's pass a bunch of values. Let's pass a 2, 3, 4, or maybe a 5 and a 6. But I want to write a switch statement to process this, a switch expression to process this. So what I'm going to do here is to say public, and then of course, let's say I'm going to return a string, and we'll call the process with an input right there of type integer. Now, we can say return switch, and I cannot tell you how happy I am to put those two words, return and switch, on a single line. And we can do a switch on that input. Now, unlike the switch statements, the switch expressions paths are auto-breaking. So we don't have to put the break keyword anywhere. So that makes the code a lot more safer, easier to work with, less error-prone as well. Well, the switch expression will evaluate one or the other path, and whatever is the result from that path is automatically returned, and like I mentioned, it's auto-breaking. Now let's take a look at how we could write an example of that right in here. So I'm going to say case 1, and I'm going to simply return a value of 1. Hey, that's great. What if it's 2? Maybe I'll return a 2. And what if it's something else? We'll say default, and we could say got something else over here. So when we run this code, obviously, you're going to see that it's going to say 1, 2, and something else for everything else that we see in here. Well, it would be nice to go ahead and print those out, obviously. So let's go ahead and do that right here so we can see the output. And as you can see in this case, we're calling the process with all those values 1 through 6. And the result obviously is 1, 2, and something else. However, if you really want to have multiple cases for a single path, you can do that quite easily. So for example, I'm going to say 2, maybe 4, and maybe 6. And we could say these are even, and we can provide those implementation for multiple values as well very easily. On the same token though, if you want to provide multiple lines of code for a path, you can do that quite easily as well. So in this particular example, we do have a default, but what if we want to do something special for the number 3, if you will? So we can say case 3, but in this case, maybe I want to do some extra work, so I can go ahead and say output, and how about say do some work here, and we could do some work along the way here. And when we are done, we can simply do a yield. Well, it's basically returning a value from that particular path and then processed, let's say 3, and we can return the value for that. So as you can see, it says do some work here and returns process 3, and essentially that path is taking effect. So we can use switch as a expression, not just as a statement. Now you may wonder, why bother with that particular effort? Well, part of the reason is it removes the need for mutating or causing side effect. So the code is less error prone, easier to understand, unlike the statement counterpart of it. Secondly, the benefit here is reduce ceremony and noise in code. We don't have to be writing as many if and else statements nested throughout. Instead, we can simply write beautiful switch, which are very expressive. I've done this in a lot of different languages because it really eliminates a ceremony in code. But more important, what excites me is this is leading to something in the future, not too far away, but in the next couple of years, is how we can benefit full blown with this idea with pattern matching. I cannot tell you how eager I am to wait for switch expressions to evolve into full-blown pattern matching, and that's going to be really awesome to be able to write very expressive code. Well, let's talk about something else we all have dealt with, something we are never proud of. Well, way back in the Java days of the ceremonious world, what did we really do? Well, we often have to manipulate strings. So maybe, for example, we are calling a function called greet, and we are passing to it our friend Joe. Now, how do I write the greet function? I want to greet my friend Joe, so I'm going to say public static, let's say string greet, which is going to take a string name, let's say, and we'll start with this incrementally and work our way through. I'm going to say message is equal to hello there. Well, that's my first line of message. I want to return the message when I am done with it, and you can see it says hello there. But this is going to be maybe multi-line. So I say message plus equal to, and then we are saying, how are you? So how are you with that little question as we can ask. And then, of course, we can again add something to it, welcome, let's say welcome to the modern Java. And that doesn't look really modern at this point, but we can wait till it actually changes. Well, the formatting is not exactly what we wanted. If we really wanted them on multiple lines, it's going to get only worse from here, trying to put all those end-of-line characters, and nobody is proud of writing this code. I mean, you don't write this code and go home and tell your family, look, I wrote some amazing code today. Instead, you say, damn, I don't want to talk about it, right? So that's the whole point is, this is not a code we are proud of, not something we'll share with our family and friends. So what do we do about it? Well, that's where the text blocks nicely come in. So what do text blocks do? Text block eliminate the ceremony of the writing, and we can easily write a multi-line string. Let's go ahead and do that right in here. So we can write those three as three different lines, but we start with a triple quote as you can see right in there. Then let's go ahead and leave the double quote as we would like to because we want to see that in there. But we can remove this ceremonious end. And of course, we can simply say welcome right there. And we can easily write the double quoted string as we can see right there. And of course, we can end that right there with three double quotes as well. When we run the code, of course, notice how it says, hello there, how are you? And welcome to modern Java. Now, what if we were to take this code and move it slightly ever so just to keep it in alignment with here? And let's see what's going to happen right now. Well, you can see that it's actually shifting back and forth, but we can remove that ceremony altogether. Now, what if I were to move this in here? Well, notice this extra spacing that's there. However, when we execute the code, that is actually not there in the output. Isn't that really awesome? What's going on here? Well, that's basically one of the cool things is very smart indentation. So we don't have to do escaping as you saw. We didn't have to put a backslash before the double quotes. But also the indentation was very sensible. It was able to identify that we really did not mean to indent in the beginning and very smartly avoided it. But of course, if you really do want indentation, you can absolutely ask for it and you get where you wanted it. Now, not only that, what if you really had some white spaces right there in the end, as you can see? Now, obviously, you don't want those white spaces. And here's the good news, you're not getting them. Just to illustrate the point, let's go ahead and say replace over here and replace the white spaces with, let's say, we want to replace them with a tilde so we can actually see them. So notice where you see them. You definitely do not see them after the how are you on that line because those were removed out even though you had the white space sitting right there. So this is really nice because if you really take this from other places, copy and paste it, you're not being punished for doing so. Now, so the trailing white spaces are gone, but there's always exception to rules. So there are some new escape sequences you have available. So what if you don't want this to be on a separate line? Well, you can then ask it to bring that over, and you can see that in this particular case, you can ask it to combine this. Let's try this again. You can ask it to combine the two things from multiple lines as well. Well, it's telling me it's an illegal character here, but nevertheless, I'm going to skip over that, but you should be able to concatenate multiple lines. So you can say, I want this to continue on the next line. You should be able to say it. But what if I really wanted an extra space towards the very end? Well, you can also enjoy that. Notice at the end of hello there's 3 squigglies to indicate that the spaces were preserved. If I were to remove it and execute it, notice that it doesn't exist right now. So that's another nice thing you can do. But you say, all right, but what about string interpolation? Well, not quite, maybe in the future. But for now, you can use a replace function like I showed you here. So what if I really want to print my friend's name over here? So I could say name and replace that with the name, as you can see right in here. So we could say hello $name and use it so. So hello Joe, how are you? That's one way. Alternatively, you can say formatted, and in this case, you can simply provide the name. But of course, instead of a $name, you could simply use a %s. So you can do formatting like we do in strings. And you can see it says hello Joe right there. So that's basically how text blocks can remove a lot of noise in the code. Well, that brings us to the next thing I want to talk about here, which is records. I can't tell you how happy I am to see records. Records are data classes. Well, in the past, we wrote classes with the getters and potentially setters, the constructor, the equals method, the hash code, forgetting to write one and creating a mess of it, writing the toString method. My goodness, what a ceremony. So we often went to third-party libraries, but shouldn't the language be doing the right thing? Well, that's exactly what records are. Records are data classes. The properties are immutable. You can get the properties. You get a bonus of a toString method in it as well. You cannot extend a record from other classes. They already extend records, but you can implement interfaces if you really want to. Records are final when they are written. You cannot extend from a record. Well, a lot of talking. You say, show me the code. Of course. So let's give it a try right in here. So I'm going to create a location. So I say location equal to new location, and maybe I'll provide some kind of a location, 131 comma minus 42. I have no clue where in the world it is. So if you find that to be a federal prison, I'm not alluding to anything. So in this case, I want to simply output the location we just created. But how do we create the location class? Well, we don't want to write the getters and the constructors and the toString method and all those hash code. No. We don't want to write that. We want to represent an object that carries data in a very low ceremonious manner. Well, enters record location, and we'll say double in here, maybe latitude, and double here is longitude. And let's start with that. Just to make it a little bit more interesting, let's say 23, a little off shift from where we are. When I run the code this time, notice the toString method was a bonus. So we have a constructor available already, and we have the object location with lat and lon provided. We can easily get the properties separately. So location.lat gives it the latitude, for example, and similarly you could say, in this case, location.lon, and you can get the longitude as well very easily. But these are immutable, so you cannot modify the lat or the lon. The toString is already available, but here comes the charm. You also have an equals method provided automatically. So if you said location is equal to, in this case, I want to say equals, and what am I asking equality for? Well, another location, which is 131.23 comma minus 42.12, and notice the response is a true. But if you were to modify it ever so slightly, the response is false to tell us it is really not equal to. But you can also add methods to records if you really wanted to, and you can create records within functions. This especially can be really useful if you really wanted to create a little record within a function to operate. I always complain that Java doesn't have tuples. Well, records can be easily tuples. You can just create them on the fly, use them within function, and forget it. So it gives you the convenience of writing code like tuples do without the burden of creating a separate class and maintaining it. They are very localized to functions. Pretty awesome, isn't it? Oh, by the way, what about error checking on the constructor? Well, that's where you can add a canonical constructor if you really wanted to. So for example, what if I had said 422? That's out of the world, literally speaking, isn't it? Well, as a result, we don't want to permit that. Well, we can easily do that by saying public location, and here we can say if lat is greater than 180 or ln is greater than 180, and obviously you can put more checks in there for less than values as well. Then you could say, for example, throw new runtime exception in this case, of course, or you can say invalid argument exception, whatever you choose. And then we could say, oh no, whatever response you want to throw at this point, you can definitely do that as well. So if in this case we said a 422, what if I make that positive value? You can see that it blows up. So that's a way for us to implement our canonical construction, where a constructor, where we can use the variables that come in through the constructor arguments very so easily. Well, that brings us to the very last thing I want to share with is the beautiful concept of sealed classes and interfaces. What in the world are sealed classes? Well, in programming sometimes we go between extremes. As we know, an abstract-based class can have any number of instances. Any number of derived classes. Venkat is sleeping at the wheel. Well, abstract-based classes cannot have instances, but they can have any number of children. On the other hand, final classes cannot be inherited from. Well, that is two different extremes. You can have as many children as you want to. Okay, that sounds really scary in real life, but you can have as many extended subclasses as you want to. But on the other hand, you could also restrict to none. But on the other hand, there are times when, as an author of an abstraction, you want to restrict the children, the derived classes it can have. This leads to what are called algebraic data types. So in other words, you want to create a set or a closed set of classes. And this is where the sealed classes come in. Let's take a little example and play with it and see how that works. So I'm interested in the compiler being happy right now, and right now it is. But let's say traffic light is equal to new red. Well, and then I'm going to just print out the traffic light. That doesn't exist, so it broke, but we're going to create a sealed class hierarchy. Let's create an inheritance hierarchy. You could create a class or an interface. Let's stick to an interface right now. So edit a traffic light.java. So I'm going to go ahead and say my interface, we'll say public interface called traffic light. And in this case, the traffic light interface, it doesn't have a whole lot. But I'm going to create a class. The class is called red, which implements, if you will, the traffic light. And so similarly, I'm going to go ahead and implement two more, the red, but also a green. And then, of course, we'll also implement a yellow as well. Now, clearly, these things have different behavior in different parts of the world. But as you can see in this case, I've created a class called red that I'm using. But what I would like to do in this particular case is when I create the class interface called traffic light, I'm going to say this is going to be a sealed. Obviously, I cannot make these public because they're all in the same file. But notice what I'm going to do now. I'm going to go ahead and say this is a sealed interface. Now, by making it sealed, obviously, I'm getting an error. But what is the reason for it? Well, now, because this is sealed, these are the only children that are permitted. But how do we know those are the only children permitted? Well, this is the special case, a simple case. All the derived classes for that particular interface or a sealed class are in the same exact file. They are located in one unit, if you will, of the file. So as a result, we can mark them as either final or sealed and so on. And you can see that it printed red right there. However, this has a few limitations now. This particular class or interface which is sealed can only have 3 children and those specific children. However, what if I were to create yet another child outside of this file? Well, that's prohibited in the simplest form. So if I were to go back here to edit, and we'll call this as a broken light, as in my neighborhood sometimes, and I'm going to create one that is actually, maybe a blinking light. How about that? That's a much better positive way to say it. So blinking light, sometimes that's just designed for me when I drive and confuses me. So the blinking light, what does that do? I'm going to say final class blinking light is going to implements, of course, and implements a traffic light, as you can see. Well, unfortunately, though, for me, I cannot write this class because I'm outside of this file, again, in the special simplified case. So when I run it, I get an error. Class is not allowed to extend sealed class, as you can see. So I'm not allowed to extend the blinking light from the sealed class. So what do I do if I really want to do it? Well, I got to get some permission. And that permission is to use permits. And this says red is okay, green is okay, yellow is okay, and a blinking light is okay as well. So that's a generalized case where an author of a class can give permission for other classes in other files to be part of that closed set of class hierarchy, and the sealed class provides us that particular benefit. So in the most special case, we don't put any permits here, but then the classes that can be part of that closed hierarchy are in the same exact file. But in a more generalized case, we can say permits, and then we can list those that are available, some of which possibly could be in the same file, but they can definitely be in other files as well. Well, so that brings us the question, what is the benefit of having sealed classes? Well, for one, you can create a hierarchy where you can limit what classes can inherit from that. This gives you control over the hierarchy leading up to algebraic data types. You can mix and match records and sealed classes too. But one really exciting things I'm looking forward, both for records and the sealed classes, if you will, is not just those two alone are not exciting. They are exciting, they are useful, and I'm happy to see them in Java. But both records and the sealed classes are going to lead us to something even more brilliant. And that again is pattern matching. So in the future, we're going to see some amazing facilities with pattern matching. I'll give you 2 quick scenarios where this will be helpful. In the case of records, we can do deconstruction or destructuring to easily extract data from records. In the case of sealed classes, you can have cases where you don't need to have a default if you have covered all the cases of a sealed hierarchy. And if you were to add a new class to your hierarchy, legitimately that is, your switch will fail compilation because now you're no longer handling a situation that is expected. So that can detect errors really early on and help us to write maintainable code that is easier to understand, but also minimizes the chance of errors as well. So to summarize what we talked about, some new features of Java that I'm absolutely thrilled are the pattern matching of instanceof or smart casting or smart instanceof, the switch expression rather than being a statement and how that leads to pattern matching eventually, text blocks removing all that ceremony and giving us ability to write multi-line strings very easily, And of course, records as data classes with immutability leading up to pattern matching with a deconstruction or destructuring eventually, and sealed classes giving an algebraic data type, again leading up to pattern matching in the future, where we can write very elegant pattern matching without the need for defaults, and making the code more error safe, or be able to take advantage of better compiler support. Well, I hope you found this useful. I thank you so much for joining. I really wish I could be there in person to meet you all and shake your hands, but I hope that will happen in the future. Please stay safe and take good care. Thank you.